Students, this is the next class on sustainable engineering. So today we will be studying about the module 4. So in the module 4, the main topics are resource and its utilization, basic concepts of conventional and non-conventional energy, an idea about solar energy, fuel cell, wind energy, hydropower plants, biofuels, energy derived from oceans, geothermal energy. So this is an idea about the renewable and non-renewable energy sources and the conventional energy, or the conventional or non-conventional energy sources and solar energy like that. So it's a very common topics are as usual in all of our modules. This is also a common topic. So we will be studying now on this, that is resource and its utilization. Okay. So what is a resource? So resource is a stock or supply of money, material, staff, energy and other assets that can be drawn only by a person or an organization in order to function effectively. So that is known as a resource. Resource can be anything. It can be money, it can be material, then it can be energy, or it can be staff or any other assets which can be drawn by an organization or a person to do a particular function. Okay, so in order to carry out a particular function, we need some energy is needed, or some money is needed, or material is needed. So such a thing is known as resource. And the resources, again, you know that resources are natural resources are there. What are natural resources? Natural resources are something which come from the nature and the people cannot make natural resources. Examples are water, wood, iron, coal, etc. Then another, that is a natural resource. Resources like hydroelectric energy are not natural because, for example, what is hydroelectric energy? We are hydro, from the movement of the water falling into the blades, we are producing electricity. So that is not a natural resource. It is a man-made resource only. So directly, if you are using something, that is meant by natural resource. That is a water, wood, iron, coal, etc. These are the examples. Energy is the ability to do work. The word work means transferring energy from one place to another. Energy is neither created nor destroyed. It can be only changed. You all know that. These are the things which are mainly with the concepts in the Newton's law or anything. Energy, that is, we are only changing the form of energy. Some days we will be having a potential energy. For example, how is the electricity is produced? We are storing the water at a higher level and the water is allowed to fall to the blades. So what is happening? The potential energy is converted into kinetic energy, and that kinetic energy is converted by the blades, by the turbines, into the water electricity. Okay, so likewise there is only a conversion of energy is being done. Okay, that is, energy is converted from one form to the another. And there are different types of energies there. These are things which you study in your this module. That is, there is thermal energy, electromagnetic energy, nuclear, chemical, electrical, mechanical, radiant energy. These are the different types of energy. Now, one classification of the type of energy is the renewable energy sources and non-renewable energy sources. You know what is renewable? That is, energy resources that are directly available, immediately accessed, and can be in a short period of time replenished. So solar energy, wind, geothermal, hydropower, biomass, etc. are renewable sources of energy. Then another, it is non-renewable source. What is non-renewable sources? The coal, petrol, example, petroleum products, etc. These are the non-renewable sources. And the important thing is that over 85% of the energy consumed in the world is from the non-renewable sources. You know all these things. Now this is a graph showing the types of energy. There is a contribution of various energy sources in energy. In India's scenario, what is happening? That is, here coal 55% is there, natural gas 7%, diesel, then nuclear, hydro large facilities, so then other renewable sources only 24%. So more than 55% we are using coal. So these are the things that is giving rise to the increase in the greenhouse gases, and that is leading to the ozone layer depletion, like that. So our basic thing is that we should use renewable energy sources by conserving the non-renewable energy sources. Another type of classification is conventional energy sources. What are conventional? Conventional energy sources generally include non-renewable energy sources like oil, gas, coal, etc. Developing these sources requires that the negative environmental, social and economic impacts be minimized. Developing then they form from the decaying plant and animal matter, which takes hundreds and millions. Most of these sources are burned to produce energy through power plants and automobiles. Okay, what are the effects of conventional energy sources? So these are things you know, that's why I'm reading it. I'm going in a little bit of fast. That is, being carbon based, natural gas, oil and coal stored carbon as potential energy and release it when they are burned. The Intergovernmental Panel on Climate Change states that carbon and other greenhouse gas emissions are a major reason for the climate change. So, that are the effects. Conventional energy sources are non-renewable, hence these sources may be depleted due to the overuse. So, we must avoid this overuse. Another type is non-conventional. That means the non-conventional energy sources. So, non-conventional energy sources generally are renewable energy sources. They are pollution free and are eco-friendly. Okay, these are the different non-conventional solar energy, then wind energy, fuel cells, hydropower, biofuels, tidal, geothermal energy. These are the different types of non-conventional energy sources. So, this is the introduction. So, first thing which we have to study is the basic concepts of conventional and non-conventional. That is the thing which I have explained. So, conventional and non-conventional. Now, we are going to study in our, as per the syllabus, we need to look into this various non-conventional energy sources like solar, wind, then fuel cell, etc. So, let us look into that. The first one, it is solar power. So, sun is a source of all the energy on the earth. It is an inexhaustible source of energy and zero emissions of greenhouse and air pollutant. 0.1% of solar energy that reaches the earth can fulfill the only 0.1% can fulfill all the energy that is needed for the planet. Then solar energy can be captured in two forms, heat energy and electricity energy. Solar energy technology comprises of two different categories, solar thermal conversion and solar photovoltaic conversion. In solar thermal conversion, solar energy is converted into heat energy. Photovoltaic, which is converted to electricity. So, solar energy can be captured in two forms, heat energy and electricity energy. So, both are different in two technologies are used. One is the thermal conversion, other is a photovoltaic conversion. That is the solar cells we are using. So, it can be converted into electricity. Solar energy is converted. In what is with solar thermal conversion? That is, in solar thermal conversion, we use the thermal part of the radiation spectrum to heat a working fluid by thermal conversion in a solar collector. In all thermal conversion processes, solar radiation is absorbed at the surface of the receiver, then which contains or it in contact with the flow passages through which a working fluid passes. As the receiver gets heated up, the heat is transferred to the working fluid, which may be air, etc. Air, or it can be in any form, water, oil, etc. The maximum temperature that can be achieved in solar thermal depends upon the insolation, the degree at which the sunlight is concentrated, and the measures taken to reduce the heat loss. That is how much it will be. Now, this is a line chart. We will be having a collector system, then a fluid can be there, there is a storage, then thermal energy, then boiler will be there, then the steam will be produced, then heat engine, heat is rejected, then there is a generator, electric energy, then waste heat, etc. So, this is a small line chart only. So, a collector system, the thermal energy will be there, it will be into storage, that fluid will be there, the fluid will be passing, then there will be a boiler, then there will be heat engine, like that. So, it is a small, you just understand the line diagram only, what are the things that is happening. Then what is in the solar photovoltaic conversion? That is, in solar photovoltaic conversion, solar energy is converted into electricity by the means of solar cells. Okay, that is solar cell. Solar cells are made up of, what is made up of? Semiconducting material that converts sunlight directly into electricity. Solar energy works on the principle of photovoltaic effect. You know that. That is, when the light falls on a certain metals like silicon, the electrons get excited and escape from the metal, which are then collected by another metal and pass through a steady stream. The electron flow thus set up the electrons flow thus set up that setup that constitutes the electrical current. Whenever the electrons are flowing, it will be the current will be flowing. Okay, that is a photovoltaic conversion. Photovoltaic cells make use of the property of semi conducting materials such as silicon. In their pure crystalline form, the electrons are tightly bound and the materials are poor conductors of electricity. Any impurity such as phosphorus, arsenic or antimony, when introduced into the silicon crystal lattice, leaves one electron loosely bound, and this free electron permits the electricity. Then the silicon doped in this way is known as N-type silicon. Conversely, if pure silicon is doped with boron, aluminium, etc., that will gallium, etc., one unfilled space in the crystal lattice known as hole. Silicon doped in this way is known as P-type silicon. So silicon, that is can be two type, N-type and P-type. So just have an idea what is happening. One, there is a loose electron, other we are having an excess electron is been added by doping. The photovoltaic selection, how it is converted, that is a silicon photovoltaic cell consists of a single crystal of P-type silicon which with a surface layer of N-type silicon. There can be N and P-type. When the light falls on the P-N junction, being an electron and the hole move in opposite direction. There will be electron in one direction and hole move in opposite. If the electric circuit is connected across the junction, an electric current will flow. By assembling a large number of cells in an array and by providing protective encapsulation, all an electrically generated system can be constructed. Electrically generating system can be calculated. So NP type silicon, they are kept together, and at the NP junction the hole and electron will be there. They will flow in the opposite direction, and if it is connected, then that will give rise to the flow of electrons, and thus electricity is produced. That is a photovoltaic conversion. So what is solar energy? That is a energy from the sunlight, and the solar energy can be captured in two forms. How it is? Heat energy and electrical energy. And how this heat energy and electrical energy is captured? By two mechanisms. That is, one is solar thermal conversion, another is solar photovoltaic conversion. Okay, so just have an idea about what are these two. Then some of the applications of solar energy. Solar water heating. You know that solar water heating systems include storage tanks and solar collectors. A sun-facing collector heats a working fluid that passes into a storage system for later use. Solar water heaters are active and passive. So these two types are given here. Okay, you know that what is solar water heating. This is another line diagram showing the active system. This is another line diagram showing the passive system. So just have an idea about this. There are two types of solar water heaters, active and passive. Okay. So another application is solar space heating for of buildings, the heating of the building. That is, passive solar space heating involves the design of the buildings to absorb, store and redistribute the thermal energy without the use of mechanical equipment. This effect can be achieved through the use of specific materials, architecture features and understanding of thermal fluids. In active heating, collectors are required to absorb the thermal energy and redistribute the heating fluid. The heat transfer medium could be air or water, etc. So the solar space heating for the buildings, it is mainly used. So this is an example. That is, here the air circulation will be there. We will be providing the heat radiation will come inside. This is a passive heating system, mainly used in the cold countries. So we can use this. Another type, it is an active heating system. Again active. Here we are in the roof, we are using open air. Then we are having a heat accumulation concrete is there. Then an auxiliary heat source for room heating is also there. So this is the active heating system. So next example is solar air conditioning. You know that solar air conditioning refers to any air conditioning system that uses solar power. This can be done through passive solar thermal energy conversion and photovoltaic conversion. Different types can be used. Then this is solar refrigerate. That is, solar refrigeration is generally required for food preservation or storage of biological materials. Then solar drying. That is, solar drying of agriculture and animal products is the most ancient and traditional and widespread methods of utilizing direct solar energy. It is a cheap and a simplest way to dry crops in regions having abundant sunshine. Another is salt production. Solar evaporator of seawater has been a traditional method of obtaining the salt. The areas where evaporation exceeds rainfall, a shallow pool or a pond will be pond of brine is exposed to the sunlight, which results in evaporation, and thus we will be getting the salt after evaporation. Then solar cooking, another example. A typical solar, it is shown here. There will be an insulation, and inside the we will be keeping the the utensil. So solar radiation penetrates a glass cover and are absorbed by the blackened surface. Here it will be the blackened, and thus it will increase the temperature inside the box, and thus it will result in heating. Then solar greenhouse, that is, a greenhouse is a closed structure covered with a transparent material which acts as a solar collector and utilizes the solar energy for the growth of plants. The incoming short wave solar radiation can pass through the greenhouse glazing, but the long wave thermal radiations emitted by the objects within the greenhouse cannot escape through the glazed surface. So such a ways, what will be happening? The inner temperature will be rising. So that will be so greenhouses can be used for the production of some plants or vegetables, etc. we can use. Then solar greenhouses, another same explanation, that is, the radius go trapped inside the greenhouse causes increase in temperature. The air inside the greenhouse gets enriched with carbon dioxide, and the moisture losses is reduced due to the restricted transpiration. All these factors help the plant growth to sustain during night and colder months. So mainly used in the cooler areas only. Okay. Then solar furnaces. Solar furnace use a huge array of mirrors to concentrate the sun energy into a small space and produce a very high temperature. Solar furnace can be used to generate extremely high temperature, that is as high as 3500 degrees Celsius under very clean conditions. They can be used to melt refractory materials, etc. Solar desalination. Solar radiation is admitted through a transparent airtight cover of sloping sheets of glass into a shallow blackened basin or pool containing brine. Solar radiation passes through the cover and is absorbed and converted into heat, causing the water to evaporate from the brine. The vapor produced get condensed and to form pure water to underside of the cooler cover, from flow down to the sloping roof and get collected. Thus we can use it for desalination. Okay, this is an example. So here we will be having a glass cover. Then here the water will get the water will be due to the temperature rise, the water will become vapor, and it will be come in the lower portion of this glass cover. So it will slowly, as the concentration increases, this water will flow, and we can take the water through this side. Okay, so likewise we can desalinate the water. That is another example. Then solar electricity, that is, solar thermal power plants use sun rays to heat a fluid to high temperature. The fluid is then circulated through pipes so that it can transfer its heat to water and produce steam. The steam is converted to mechanical energy in the turbine. The turbine produces a generator to produce electricity. That is example of a solar thermal power plants. Then these are some of the examples. So next is what are the advantages? The energy from the sun is free. The sun does not produce greenhouse gases. The sun and sunlight will always be there during your lifetime. That is the advantage. What are the disadvantages? Main disadvantage is they are expensive. Solar panels are expensive. When it is cloudy or at night, there is not enough light. Large area of land is required to capture sunlight. Large area of land is also required. So these are the things you need to have an idea about the solar. So what is solar energy? And what are the different forms in which by heat and by electricity we are using, thermal and electricity. Then some applications of solar energy that you can write in your own words. What are the applications? I have given almost 11 applications here. Try to study some of the applications. Then what is the advantages and disadvantages of a solar energy? So these are just things you need to know about in solar energy. Another thing is the fuel cell. A fuel cell is a device that generates electricity by chemical reaction. Okay, a fuel cell have two electrodes, anode and cathode is there, and an electrolyte is there. The reactions that produce electricity takes place at the electrodes. Fuel cells produce very little pollution. Mostly Many fuel cells are serially connected and assembled to a stack. Working of the fuel cell. There are several kinds of fuel cells and each operate a bit differently. But in general terms, hydrogen atoms enter a fuel cell at the anode and a catalyst causes the fuel to undergo oxidation reaction to generate ions and electrons. The hydrogen atoms are now ionized and carry a positive electric charge and move from anode to cathode through the electrolyte. At the same time, the negatively charged electrons provide the current through the wires to do the work. So it will be connected. If alternating current is needed, the DC output of the fuel cell must be routed through a conversion device called as inverter. So if AC is needed, then the DC output of the fuel cell must be routed through a conversion device, so that an inverter is used so that it will convert into an AC if it is needed. Okay. So this is the a example of a fuel cell, working of a fuel cell. Okay, that is working is explained here. That is, we will be having the hydrogen ionic gas ionized, then there will be a motion of the positive particle and negative particle, and the negative particle will result in the formation in the current formation. Okay, that is the main. There are different types of fuel cell: alkaline fuel cell, molten carbonate fuel cell, then proton exchange membrane fuel cell, solid oxide fuel cell, phosphorus acid fuel cell, direct alcohol fuel cell, etc. Whatever may be the type of the fuel cell, their basic operation is always the same. Okay. Again, the advantages and disadvantages. The energy conversion is efficiency is high. It is eco-friendly and sustainable, as water is the only byproduct. A number of fuel cells can be connected in a series to generate a required output. And what are the limitations? Again, high initial cost for the fabrication of fuel cell, high cost of electricity generated, and if gas is used as a fuel, they have to be stored in big tanks under high pressure. Okay, so these are the advantages and limitations. So that is the thing about fuel cell. So what is a fuel cell? Just an idea about how it is working. Then what are the types, as well as what are the advantages and disadvantages. So in all the throughout this module, we will be we need to study about different energy, conventional, non-conventional energies. That is solar energy. So what we are studying? What is solar energy? How it is converted? Just an idea about how the process is being done. Then what are the advantages? What are the disadvantages? And what are the different types and applications? So these are things which we need to study generally in all the topics. So solar energy, fuel cell. Next one, it is what? Wind energy. So let us look into wind. You know that wind is the most important. It is the important source of non-conventional energy. The kinetic energy of the winds can be used to run wind turbines to produce electricity. Wind turbines vary electricity. Windmill farms are erected in areas where the speeds are high enough to produce viable amount of energy. Working of a wind turbine. How is a wind turbine? A wind turbine is a machine which converts kinetic energy into kinetic energy in wind to electricity. Kinetic energy in the wind turns a propeller like aerodynamically designed blades which is mounted around a rotor. This mechanism converts kinetic energy into mechanical energy. The rotor is connected into a generator by a shaft. Generator converts the mechanical energy into electrical energy. So what is happening here? The kinetic energy is converted to mechanical energy, and that mechanical energy is converted into electric energy. So that is being shown here. So here the wind will be flowing. This is the blades. It will be moving. So there will be a shaft. Then mechanical energy will be created. Then using that, the generator will be working, and likewise will be producing the electric energy. That is, a generator converts the mechanical energy into electrical energy. Okay. Then again, what are the advantages and disadvantages? Wind is renewable. Wind is free. No greenhouse gases are made. There are few safety risks. Safety risks are less. The disadvantages are lots of wind turbines. Lot of wind turbines are needed. Turbines can only be put in windy areas. In every all the places we cannot place. It depends upon topography of the land, the average wind speed, etc. It is not always windy. Some people do not like that. So there are an appearance like this. It depends upon there can be different disadvantages. So main disadvantage is a large number of turbines are needed, and everywhere we cannot use this. That is the main disadvantages. Okay. Next one, it is the hydropower. So the generation of electricity from hydropower sources is a low cost, environmental friendly and renewable. It is our future resource which is very helpful for the upcoming generations. Small hydropower plants, HSP, small hydropower plants can provide clean, renewable and relatively inexpensive energy. Unlike a large hydropower, small hydro does not necessitate a reservoir is not needed. They can be constructed in any location where there is enough water flow and head to make the energy. Can be constructed across irrigation canals, waterfalls or hilly areas. Small hydropower plants are gaining importance these days because in large hydropower we need to create dams, and the creation of a building of a dam is causing many problems to the environment. So small hydropower plants should be used. That is very much needed. The advantages of these are the small hydropower plants is a clean energy source producing minimal impact to the environment. There is a renewable energy source. Hydro power stations are able to achieve high efficiency compared to other. Long use life, 50 to 100 years of working cycle, low running cost. Since no reservoir is created upstream, there is minimal impact on the neighborhood communities, etc. Again, there are some disadvantages for these small hydropower plants. That is, to be economical, energy consumers need to be located near the hydropower scheme, thus limiting the application. The stream flow limits the power generation. Seasonal variation in the stream flow causes variation and disturbance. Advanced planning is needed to ensure adequate energy generation throughout the year. Advanced planning is needed. Okay. So these are the different advantages and disadvantages of small hydropower plants. You need to understand here it is written as small hydropower plants only we are studying. So that is the importance. Okay. Not on large hydropower plants. Okay. So these are the things you need to know in your small hydropower plants. Okay. Okay. So with this we will be minding the class. So today we have discussed about the basic concepts of conventional and non-conventional energy sources, an idea about the solar energy, fuel cell, wind energy, and small hydropower plants, SHPs. Okay. So next things which we need to study is the biofuel, energy derived from oceans, and geothermal. Three more types only we need to study in this module 4. Module 4 is very little compared to other modules. Okay, very easy modules only. So that's all for this class. Thank you.